Hey everyone, as one of the lead researchers on this project, I'm really excited to walk you through a breakthrough we're calling Atom of Thoughts, or AoT. It's a totally new way to think about how an AI reasons, one that makes it not just more powerful, but believe it or not, dramatically more efficient.
So let's just jump right in with a massive question in the AI world today. Why is it so incredibly expensive to get an AI to do any kind of complex, high-level thinking? And I'm not talking a little expensive. This is a major bottleneck that's really holding back progress for everyone.
Well, it really boils down to what we've started calling the high cost of thinking. You see, the most common AI reasoning methods we use today, they're pretty powerful for sure, but they're also dragging around a huge amount of computational baggage that just slows everything down.
Let's get into the weeds a little bit. Think about popular methods you probably know, like chain of thought, or COT, and tree of thought, TOT. For every single step the AI takes, it has to lug its entire reasoning history along with it. Imagine you're solving a puzzle, but with every piece you place, you have to go back and reread every single move you've made so far. This history prompt just balloons, leading to tons of redundant calculations and, you guessed it, costs that just spiral out of control.
And look, this reasoning baggage, it's not just a minor inconvenience. It has some really serious consequences. It makes the whole thinking process slow, ridiculously expensive, and actually pretty fragile. If the AI makes one tiny mistake early on, that error gets dragged through the entire chain, and it can totally derail the final answer.
Right. So this got us thinking, what if we could just get rid of all that baggage? This simple question led us down the path to a memoryless approach, which is inspired by this cool mathematical concept called a Markovian process, where the past doesn't weigh you down. To put it simply, a Markovian process is a lot like a game of chess. Your next move, it only depends on where the pieces are on the board right now, not the entire history of every move that got you there. It's a clean, focused, and incredibly efficient way of solving problems, precisely because it lets go of the past.
And this slide, man, it just lays it all out, right? On the left, you've got the old way. These long, messy, tangled chains of thought, carrying all that historical baggage. And then on the right, you have our approach. These clean, self-contained problems, what we call atoms of thought, that get solved one elegant step at a time.
Okay, so you're probably wondering, how does this actually work? What's the magic here? Well, AoT uses this really elegant two-phase process we call decomposition and contraction to create these atoms of thought. Let's break it down. All right, let's get our hands dirty with an actual example. Take a look at this pretty complex math word problem here. A traditional AI might just dive in and start scribbling out this long chain of calculations. But AoT, it looks at this completely differently.
First up, we have decomposition. The AI looks at the problem and basically draws a map of all the little calculations it needs to do. It figures out which steps depend on other steps and which ones it can solve all on its own. Then you've got contraction. The AI knocks out all the independent parts first, and then it uses those answers to build a brand new, much simpler problem to solve next.
And this is what that process actually looks like in action. It's pretty cool. The initial question you see on the left gets broken down into this graph of individual thoughts. Then, the AI solves the pieces that can be solved and uses those solutions to contract the problem into a new, simpler question, Q1. It's the same exact problem, just stated in a much smarter, more efficient way.
Okay, so this is the part that really matters, right? The big question. Does this new method actually work? Is it just a neat theory, or does it deliver in the real world? Let's take a look at the data.
All right, take a look at these charts. We ran AoT against other methods on 5 different really tough benchmarks. On the vertical axis, you've got accuracy, so higher is better. And on the horizontal axis, you've got cost. So farther to the left is cheaper. Now just look for the red icons. That's AoT. You see how they're all clustered in that top left corner? That's the sweet spot. Higher accuracy for a much, much lower cost. And if we zoom in for a second, this is where it gets really interesting. We took GPT-4o Mini and gave it 2 hard math benchmarks. Using the standard chain of thought method, it got a respectable 78.3% on the math benchmark. But when we applied our atom of thought method, boom, its accuracy jumped to 83.6%. We see that same impressive leap on the GSM 8K benchmark too. So get this, AoT isn't just cheaper, it's actually more accurate. But for me, this is maybe the most exciting part for all the developers and researchers out there. AoT isn't an all-or-nothing system. We designed it to be a modular plugin that can actually supercharge the AI systems you're already using.
Remember how we said each atom is its own neat, self-contained problem? Well, that's the key. That makes it a perfect handoff point for other reasoning frameworks. AOC can do the initial hard work of simplifying a really complex problem and then pass that new, cleaner problem over to another powerful system, like Tree of Thoughts, for even deeper exploration.
So if you're building with AI, this is really the main takeaway for you. You can use AoT all by itself as a reasoning framework, or you can just plug it in as a preprocessor to make your current tools way more efficient. Each little atom it creates is a perfectly optimized starting line, which boosts performance and saves you money on computation across your entire workflow.
This all leads to a final kind of big picture idea. What if the future of AI reasoning isn't about trying to build one single, giant, impossibly complex thought process? What if instead the future is about creating a perfect, efficient, and truly elegant chain of these tiny, powerful atoms? That's the future we're building.